Hi, welcome back to Daily Dose of Rust. It's been a long time, so I had to take some weeks off to complete some of the projects I was doing for some clients. And I'm glad to be back, so let's get started. We're going to start off from where we left off. In the previous videos, we treated macros and attributes, okay? And in this video, we'll jump right into unit testing in Rust. This will be a series of videos where we are going to do justice to unit testing and then help you understand how you can test your code in Rust. Now, unit testing generally is something that is very useful when you are building softwares. It makes your code more robust and more durable, okay? And it makes it very easy and gives you the confidence for you to go in, modify some legacy code and jump out without having any fear that your code will break, because we always run the existing tests to make sure that the new code you have did not break anything in the past. Okay, and that is the beauty of unit test. So in this video, I'm going to give you a very simple introduction to unit test and how you can go about it to give you the confidence you get whenever you write unit tests. Now, there are many types of tests: unit test, integration test, end-to-end test, and all that. But in this case, you are focusing on unit test because it's the most basic ones. Okay, so let's get started. Okay, so to get started, let's say we are building a mathematics software and we want a function that accepts two numbers and then divide them and return the value. So we call it divide. It accepts two values, A of type f64 and B of type f64, because we want the remainders to also be returned. If you are using integers, it's not going to return the remainders. So the return value will also be of type f64, and all we have to do is to return A divided by B. So we have our function. Now, in order to use this, you have to come in here and then create a variable, let's say result1, then we'll call divide, and then pass the first value. Let's say we want to divide 5, we want to divide 4 by 5, then we can call that function this way. Since it's a floating point value, then we'll have to pass 4.0 and 5.0. We can now print this to the terminal. Now we can come in here and then run the code, and we'll get the answer is 0.8, and that is very fine. However, you know that in mathematics you cannot divide something by 0. Okay, let's try to do that. Now we're dividing 4 by 0, so if you run cargo run, we get infinity. So this is not a floating point value, and that becomes a problem and it could cause our code to crash. So in order to mitigate this, Rust has something called results, a result enum that we can use. We've treated this before. This is a way that Rust avoids using something like try catch block that other languages use. So we need to make sure that if b is equal to 0, that we don't use it to divide anything. So in order to do that, it means that we won't always be able to return a floating point value here. So we could use the result enum. Check out that video where I explained the result enum in detail. So with the result enum, we can say that when everything is fine, we will return an f64 value, or else we will return a string value explaining what went wrong. Okay, therefore right here we're no longer going to return just a floating point value, but a result enum instance using the OK variant. The result enum has two variants, okay, the OK variant and then the error variant. We are using the OK variant here to return a floating point value, which is what we described here. Okay, now what if b is equal to 0? Well, we can say if 0 is equal to b, then we will return an error. So we can still return result error. This will still return an instance of result, and then we can provide the problem. We can say, hey, you can't divide by 0, and this will make it clear to the user what went wrong. So this is a floating point value, we have to say 0.0. Okay, so now we are no longer just returning a floating point value, but a result value, and therefore we can no longer just print it to the terminal here. We have to use this debug format to allow us to print it to the terminal. Okay, so now when we run the code again, instead of getting this infinity, we get this error. Okay, here you can't divide by 0. So this way, if this was a library that we built, whoever is using it will know what went wrong. Now you can see that there's a problem. For this function alone, we have to do two things. First of all, make sure that this function is able to divide two values and return the quotient. Secondly, we need to make sure that we are not able to divide by 0. And if this was to be a function that does other things, it gets more complicated. And this is where unit test comes in. It allows us to write tests for these functions. So instead of having to come in here and test this function manually, we can just do that automatically using the codes. So in the future, if we keep adding more features into this function, we are not going to be bothered, because we will always run that test to make sure that we did not break the previous features we have. So in Rust, it's very easy to write unit tests. One of the first things you notice is that you can write unit tests inside the particular file that you are working on. Okay, so you can come in here and then start writing your tests, which is what lacks in other languages. It makes it easy for you to focus, to know where your tests are every single time. Now, we can write a test here very simply by writing a function. First of all, in order to be organized, we have to write this test inside a new module. Okay, we've treated module in detail. You can check out this video in the description where we treated that module. We can just call this test mod. Okay, and then inside here we start writing our test. So what happens is when we run our code, when we build our code and run it, Rust will not touch anything that is a test. Okay, it will only compile the test when we are running the test. Okay, now this module is not a test yet. We have to make it a test by using this attribute called CFG, and then we pass test. Okay, so this attribute is what makes this module a test. Now you can also check the video where we covered macros and attributes as well. So inside here we need to do two things. First of all, test to make sure that this function will return what it's supposed to return. Okay, if we divide two values, so we can just call that a function. We started with test divide two values, and then right here we can do the same thing we did here by calling divide directly and then passing these values. Let's say we want to divide it by 2. Now another issue you will notice is that we are now getting an error that we cannot find divide. Okay, and that is because we are inside another module, so we have to import this divide function from outside here inside this module. And there's a very simple way of doing it. You can just use the use keyword and then call super will now go outside this module, and then we can now bring in divide inside here. Okay, and this will allow us to use it. Okay, so now we have the divide function that we've called. Now when we divide 4 by 2, we are supposed to get 2. It's time to start using the assertion macros we have in Rust, and I'm going to show you this very simple one. We can say assert equal. So this will assert that what we have here is equal to what we have here, right? And since we have our result, we can say result 1. We want to assert, okay, we want to say that it should be equal to 2, because when you divide 4 by 2 you get 2. Now we have a test, but this function is also not a test yet. Okay, so we have to make it a test by using another macro called test. Okay, you can see that it's different from this macro we used to indicate that this module is a test. Now also here Rust is also warning us simply because we are expecting a result and not a floating point value. Now in order to run this test, all we have to do is to go to the terminal and then run cargo test instead of cargo run, and this will compile our test and run it. And now you start getting some helpful messages here. You can see that everything is green. It will tell us how many tests that we ran. We ran just one test, okay, and this is the name of the test. It's inside this test module, and then this is the name of that function right here, and then you can see that it's okay in green, which means we ran one test and one test passed, 0 test failed, 0 ignored, and then the rest. Now if for some reason this function did not work very well and we got something different, like let's say instead of dividing this value we came in right here and then made some modification, maybe later on while we are trying to improve the function, then after modifying the code we can still run cargo test, and this time around the test will fail, and this will notify us that hey, we just made some modification here that broke what worked earlier, and we can then go ahead and modify it. And this is the beauty of unit testing in Rust and in software development in general. It gives you confidence where you modify the code that already exists, maybe legacy codes, and also gives you the confidence that your code, you've not broken anything that was working earlier. You can see that when we made this modification, it made the test to fail. So coming back here, you can see here that we have a failed test. So this test divide two values has failed. And in fact, Rust will do you even one better by coming here and then telling you what went wrong. You can see here it says this test panicked at assertion failed. So left was not equal to right. You can see what we had at the left side. We had 1 because of this modification right here, but it was supposed to be 0. Okay, so seeing this will make it easier for you to understand what happened and then fix it. So you can go back and then modify your function to get it to work. Okay, but this is just one implementation. We also have to test when b is equal to 0, and in order to do that, you can just write another function here. You can call it test divide by 0 and then do the same thing we did here. And now we'll divide by 0. Now whenever we divide by 0, we expect the code to panic. So whenever we divide by 0, we expect it to return an error. Okay, so we can do the same thing, assert equal, and then we assert that result is equal to result error, and then the message will have to correspond with what we have here. Okay, so we expect that this message is what we will get back, so we can just copy that and then use it here. Okay, and again, this function is not a test yet, and to use the test attribute, so we can now run the test again. And here we go, 2 tests passed, and then you can see those tests that passed here. This way, whenever we make some modification to this function, we can just run the test to make sure we did not break anything. So this is a basic introduction to unit testing in Rust. Okay, so make sure you subscribe, and then in the next video we'll go deeper into other tests, testing threads, structs, and even testing other libraries as well.